So let's move to the next, the last session of the morning. So the next presentation is the RISC-V architecture for the future of generative AI and HPC. The presenter is Mr. Lee Flanagin, Esperanto Technologies, USA. 次のご講演は、生成 AI と HPC の未来を担う RISC-V アーキテクチャです。講演者はエスペラントテクノロジーズ、アメリカにあります、リー・フラナジン様です。Okay, thank you, Lee.
Thank you very much.
Would you start? So.
Thank you. So a little bit about Esperanto. We are also in the RISC-V space. We are similar to Tens Tort and Vantana, but we have a little bit of a more focused view. So first of all, our history. Our founder and CTO today is a gentleman by the name of Dave Ditzel. I think some of you in the audience know Dave. He was one of the co-authors on the original case for RISC-V white paper with David Patterson way back in the early days. And we really believe that Dave, under David Patterson back as far as 2014, was one of the earliest adopters of actually RISC-V in the industry. Today, we are focusing on AI inferencing and HPC workloads. And our approach, as you'll see in a minute, is taking a mini core approach, but at very low power consumption for both the data center and enterprise edge appliances. We believe we're actually one of the very first companies, at least in the US, to be shipping a production fully RISC-V chip today for AI inferencing. And we have recently announced a partnership here in Japan with Elementech as our exclusive distribution partner for Japan, and I'll talk a little bit more about that later. For the roadmap, today we're working with a Fortune 40 company on a 4 nanometer and 3 nanometer part. I'll share that with you in a little bit. And we're really looking to extend our leadership in AIs, but specifically for HPC. So we think what's interesting when we introduced our first generation chip, TSMC 7 nanometer chip, about 2 years ago, the market basically split in two for us very early on, where we saw about half of the customer base adopting it for AI inferencing, for computer vision, transformer, and recommendation workloads. But what's interesting is because essentially what we've developed is a CPU, about 50%, the other 50% of the customer base was approaching us for what we call HPC or HPC-like light computing workloads. And that's really kind of developed a lot of the momentum that we have today in the user base. And really what we see emerging is a unified hardware and software environment that can support both type of workloads, AI inferencing and HPC. And we're actually very excited about that future. So from a market trend standpoint, we believe we're in the early stages of another silicon supercycle. So this is a snapshot of a market report from a US firm called Creative Strategies. What they do is they call out here some interesting trends that were relatively new. One of them is, of course, the rising adoption of RISC-V. Really all of the large enterprise customers that we talk to today have some type of RISC-V strategy going on. I think all of us in this room will know that, so I won't talk too much more about that. But also energy efficiency is very key. And this is one of the fundamental aspects of the DNA of our company. So Dave Ditzel, back in his history, as some of you may know, founded Transmeta, and he's really taking that low power CPU design approach into Esperanto today. And so when we look at the new offerings from NVIDIA or AMD and others, yes, the performance is increasing, but we also see the power consumption, the power envelope increasing exponentially as well. And many of the customers that we're talking to, specifically here in Japan, have very sensitive power budgets. Many of them are adopting carbon neutrality mandates in their companies, green computing mandates. And so we believe that our solution and our technology and architecture is well positioned for that. Enterprise edge is also something too that's relatively new from a market to analyst perspective. It's a very fragmented market space, unlike the data center. So it's pretty difficult to kind of put a encapsulation around that in terms of TAM market opportunity. But as we look for compute workloads that are looking to offload from the cloud, be they smart city applications, be they on-premise retail applications, we also see that as a large driver, and of course HPC as well, as I said before. So this is a new market report that was released just a few weeks ago. They're predicting, in my opinion, a relatively conservative projection of AI SoCs reaching about $100 billion in market revenues by 2030. Their projection is that that will consume about 1/3 of all AI SoC shipping in the same time frame. And again, this just underscores the rapid adoption of RISC-V going forward. So from a use case perspective, we really see this kind of cutting in a couple of different areas here. So green computing is one, data center and edge is another. So this is something where large enterprise companies that have both data center and I'm going to call them generically enterprise edge use cases, again, are looking for a singular architecture, hardware and software to support their computing needs. We see it across the AI inferencing, as well as that kind of bottom right one is a little bit of a hybrid on the slide. We're seeing a lot of interest too in terms of, I'd say, very low power single chip implementations that could support those types of applications. So a little bit about our first chip. This is a TSMC nanometer chip. It's 24 billion transistors, about 570 square millimeters. It's essentially the same size as an NVIDIA A100. This chip, what's interesting is it supports over 1,000 64-bit RISC-V CPUs, right? So over 1,000 CPUs in a single piece of silicon. Those blue squares essentially represent compute clusters. And so those are over 1,000 64-bit. But in the upper right-hand corner, that is our actually on-chip host processors. Those are also 64-bit host processors. So this chip can actually run in self-hosted mode in boot Linux. And that is also interesting for customers who are looking to either lessen the cost of the host CPU in a system or potentially run in hostless mode altogether. This is very energy efficient, and this is just in a small example here. So this is a power graph that we took running a meta recommendation workload, and I circled the 6 watt. You could see here kind of toward the bottom, the orange line. That's actually the 1,000 running at 600 megahertz processors consuming only 6 watts of power for this particular workload. So we think that's a kind of a special achievement for ability to deliver power and performance together, and something that many customers are very interested in. Excuse me for my cold. From a software standpoint, similar to what Tenstorrent is talking about, the AI stack on the left is what we introduced for production about 2 years ago. Essentially, you can ingress this either from PyTorch or Onyx. The general purpose SDK stack on the right of the slide is something we introduced about a year ago to support the HPC and HPC Lite customers that we have today. This is initially a GCC backend compiler that we're moving to LLVM in the future. All of these come fully installed and integrated with any hardware that we ship to the market. So we have a US system integration partner that's developing a PCIe Gen 4 card for us. This is a US country of origin product. This is available, but typically what we like to do is actually ship them in pre-integrated servers. So this is a Gigabyte G292 form factor. We chose this because of its very high density capability. So this can support up to 16 of our low power PCIe Gen 4 cards. This is actually what we're shipping to market today. We're shipping it in the US, in Asia, and in Europe. We also have customers looking at rack configurations. This is an example of our own IT data center in Mountain View, where we're headquartered. Here we can support over 80,000 RISC-V processors running in a 10-server rack. Today, this is used for development by our own software team, but we expect installations and shipments globally in 2024. This is a new product that we introduced relatively recently. This is a shorter form factor, also a Gigabyte form factor. This has up to 6 of our cards in it. And what we're doing here is we're taking an approach from a generative AI perspective of not necessarily needing to support the largest parameter models that continually are introduced to the market, but really more on the smaller to medium size. We really see specifically enterprise customers looking to develop through an API layer that we offer the ability to come in with a preloaded server with pre-optimized LLMs. Here, these are just 3 examples. We have many more today. Of note, those 2 images in the bottom were actually generated by our ETSoC1 silicon, where they're actually able then to take this preloaded and develop it to their end application, depending upon what their needs. We're getting a lot of interest in this as well. So from a product portfolio today, on the far left is the G292 that I mentioned earlier. We also have cloud access for customers that are looking to do experimentation and R&D, and we have 2 smaller form factors today, both targeted for generative AI and enterprise edge applications. We've greatly recently expanded our partner network globally. So Elementech here in Japan is our exclusive partner for Japan. Penguin Solutions, based in the US, is a kind of a dual system integrator and a go-to-market partner, specifically focusing on US federal customers in particular. E4 is based out of Italy in Europe. They're working very closely with us on RISC-V mandated green supercomputing projects coming from the EU. And Megware is our go-to-market partner in Germany, focusing on many R&D and university organizations. So I'm just going very quickly here for time. So a little bit of a sneak peek in terms of what we're doing with the roadmap. So ETSSC1 is on the left, but we're well underway with both second generation and third generation silicon designs today with our lead Fortune 40 customer. The second generation design will be a 4 nanometer chip. This will be supporting LPDDR5 in a 2.5D layout. We're actually just about to tape this chip out, and we expect that to be in the market as early as mid-2025. The one on the far left, I have to obviously obscure a lot of the details here, but this is going to be a stacked memory solution at 3 nanometer. We think this is going to be very unique in terms of its capability in supporting HBM4 and delivering really pretty amazing TCO to customers. We're actually in the process today with our system integration partners and our development customer of previewing these products under NDA to lead customers globally. And the feedback we're getting is very, very positive in terms of its capability to compete with both current gen Grace Hopper 100 and next gen Grace Hopper 200 solutions from a TCO standpoint. So we're pretty excited about the future. And with that, let me just end by saying that we're very excited for partnering with Elematech. If any customers in Japan have any questions, we certainly direct you to Elematech. We're supporting them from the US. And they have a really great head start in terms of working with customers here in Japan, both at the government and commercial level. So with that, I'll take any questions. Thank you.
So thank you, Lee. So the session is open for the questions. So any questions? ご質問どうぞ。
Okay, thank you very much.
Okay? Okay. じゃあ終わりだそうです。はい。じゃあどうもありがとうございました。Okay, this is the end of the morning session. これで午前中のセッションは終わりです。ですよね、そうですね。はい。で、we're gonna have a lunch break. So afternoon session begins at 1 o'clock. So we have 1 hour and 40 minutes. So let's take a lunch break. So はい、じゃあ、お昼休憩を取りたいと思います。午後のセッションは1時ちょうどから始まります。それまでにお戻りください。今から1時間14分後ですね。はい、で、その間に、そうだ、ブース、展示ブースがございます。で、ブース見学はもうできると思いますので、ぜひ見ていってください。So booth exhibitions are available right now. So please stop by exhibition booth also. Thank you.